So what we're going to do today is solve quadratic equations. And basically, a rational expression, this is something that you know already. All right, it's an algebraic fraction whose numerator and denominator are polynomials. You can never divide by the number 0, right? So a number divided by 0 never works. That makes the expression undefined. And I'll show you on the calculator, but any number n divided by 0, if you actually read what that word says, it spells no, and that means no way. It doesn't work. It's undefined. But if we wanted 0 to be over a number, and I'll change my variable from the number n to the number n to the number k, 0 over any number is just 0. All right, so this is something hopefully you know already, that if you ever have 0 in the denominator, it never works. You get an error message. If you ever have 0 in the numerator, you're always going to get the answer that is 0. So let's see if this thing can come up, and I will show you what we mean. Okay, so if I were to go to my home screen and I said, well, what is okay. So if I were to do 10 divided by 0, I'm going to get an answer that says ERR, error, divide by 0. You can't do it. Okay, it's not possible. But if I wanted to put that 0 in the numerator, 0 divided by, and I'll just choose a different number for no particular reason, 0 divided by 7, that is 0. Okay, so you need to remember that you can never divide a number by 0. 0 in the denominator, no way, doesn't work. 0 in the numerator, okay, the answer is 0. So those values that are going to make the denominator equal to 0, those are things which cause an irrational expression to be undefined or a fraction undefined. They give them two names. Sometimes they call those values restrictions, right? So they say, well, you can divide by all these numbers except. That would be a restriction. Sometimes they call it an excluded value. You can divide by all of these numbers with the exception of this particular number, the excluded value. The other thing, and you probably know already, but never maybe really called it this, the zero product property. Remember, product means to multiply. For all numbers a and b, if a times b ends up equaling 0, then either a is 0, b is 0, or both of them are 0, right? So zero product property says if I'm going to multiply two numbers and one of them is 0, well, my whole answer ends up being 0. If I have 0 to be the first number and I multiply it by 6, the answer is 0. If I have both of them to be 0, well, then of course the answer is 0. So that's the zero product property. So where are we going to use all this stuff? Well, if you want to determine excluded values or restrictions or ways that make things undefined, you're going to set the denominator and just the denominator equal to 0, because that's what you can never divide by, right? You can never have 0 on the bottom. You're going to factor if necessary, and then you're going to solve. So if I'm looking for an excluded value, I'm going to say, okay, well, I don't care about the top. It could be anything at once. I could care less. I'm going to take my denominator. I'm going to set it equal to 0, and I'm going to solve for that variable. And what comes out is my excluded value. If r is ever equal to 8, I'm going to get an answer that never works. Any other number is fine. And let me kind of show you this on the calculator. If I go to y equals, and I take a look at that equation, which was, or that fraction, which was 5 divided by, and I need to use the letter x, right? So in parentheses, the denominator is x minus 8, right? So that's the problem. 5 divided by binomial r minus 8. If I go to my table of values, I'm going to see answers everywhere in the y values, except for when y is 8. I'm sorry, except for when x is 8. When x is 8, my answer for y is error. It doesn't work. But any other x values, whether I keep going down on positives, whether I keep going up and I hit some negative numbers, there's always going to be an answer. It might not be a pretty answer, but there's an answer. The only time it doesn't work is if my denominator, if the value for r is 8, I can never divide by 0 because 8 minus 8 is 0, and I get an error message. Okay? On the next one, numerators are irrelevant. If I take my denominator and I set it equal to 0 and I solve. Well, this is not a linear equation. This is a quadratic. I have to factor. Didn't have to factor in the first one, but this one I do. I've got a GCF of x and then x minus 2 left over, but equal to 0. So essentially, I have two factors here. I've got an x and an x minus 2. So what I'm going to do is I'm going to draw a line, and I'm going to set each factor equal to 0. Once I set x equal to 0, that's my answer. Once I set x minus 2 equal to 0, well, I have to solve for x here, and x comes out to be 2. So the two excluded values then for this particular problem happen to be 0 and positive 2. Okay, so if 0 get plugged in for x, I'd end up with a 0 in the denominator, and I'd have an error message. If 2 were to get plugged in for x, I'd have a 0 on the bottom, and I'd have an error for my solution. Let's take a look at these guys. Again, in terms of excluded values, it's just the denominator that can't be a 0. This is irrelevant to us. I'm going to take the denominator. I'm going to set it equal to 0. I'm going to factor it. This is I'm going to factor it by x plus 3, x plus 2 equal to 0. I'm going to draw my wall, and I'm going to set each factor equal to 0. I'm going to take what's in the parenthesis out, set equal to 0. What's in the parenthesis out, set equal to 0. And I'm going to solve for x. Subtract 3 on both sides. One excluded value is negative 3. Subtract 2 on both sides. One excluded value is negative 2. So there are two different excluded values that are going to make this have an error message if I try and do the math, negative 3 and negative 2. Again, numerator irrelevant. Denominator is what's going to make something be an error message. I factor this guy by dots, y minus 2, y plus 2 equal to 0. You're going to draw your wall. You're going to set each factor, or take what's in the parentheses out, set them equal to 0. Solve, in this case, for y in both of them. One y value comes out to be positive 2. The other y value comes out to be negative 2. So your restrictions, your excluded values, would be the 2 and the negative 2. All right, so let's say you need to solve a quadratic equation by factoring. So if necessary, make sure your equation's equal to 0, okay? You've got to be equal to 0 before you can do anything. Also make sure you're in standard form. If you have a quadratic, it has to be the appropriate order. It's got to be, pardon me, the x squares come first, then the x's, then the constants. If you're not factored already, decide how to do it. You're either going to factor by GCF, by dots, by IM, or you're going to factor completely. At this stage of the game, you should know how to do all this super fast. Set each factor. It might be a GCF, it might be a parentheses, a binomial factor, but set every factor equal to 0. That's how you're trying to use a zero product property. And then you're going to solve each equation, and you're only looking to solve for variables, okay? So number 1 happens to be in factored form already, and you are already equal to 0. Just drop your wall, take the left-hand side out of the parentheses, set it equal to 0. Take the right-hand side out of the parentheses, set it equal to 0. Solve for x on both sides of your wall. One excluded value is 8. The other excluded value is negative 7. Those are your answers. Number 2, you're already equal to 0. All that's left to do is factor. It's a dots problem. This becomes y minus 8, y plus 8 equal to 0. Drop your wall. Set each factor equal to 0. Solve each equation. One value comes out to be 8. The other value comes out to be negative 8. So these are your excluded values. I'm sorry, these are your solutions. Sorry, these are your solutions. Number 3, In order to solve this equation, you know what I just realized? I don't know that I explained this very well. We're not doing excluded values anymore. We're looking to solve each equation because what's really happening here, I'm going to go back to number 1 for a second. If x equals 8 and I were to plug in 8 wherever I see an x, I'd have 8 minus 8, or 0, 8 plus 7, which is 15, but when I multiplied them together, I would get 0 as my answer. Same thing for the -7. If I plugged in -7 into that first parenthesis, I'd have -15. If I plugged in -7 into the second parenthesis, I'd have 0. And -15 times 0 is 0. So we're not looking for excluded values. I might have made that not clear. We're looking for solutions. What's going to make these two parentheses equal to 0? Similarly, let's take 8 for a second, and we're just going to check this one and then move on. If I plug in for 8 for y and I square it, I get 64. Well, the rest of the equation was minus 64, and in fact, you get 0. So this one definitely works. If I were to plug in -8, well, any negative number squared is positive. So this becomes 64 minus 64, and both of these values work. So we're looking for solutions to the equations. What number or numbers can we plug into the variable, do the math, and get the answer they want us to get? If I look at number 3, what's happening here is I'm not equal to 0 yet. So in order to do that, I'm going to bring 15 over to the left-hand side by subtraction. This becomes x squared plus 2x minus 15 equal to 0. And that's what they said we had to do. I've got to factor this. I'm going to factor by I am and get x plus 5, x minus 3 equal to 0. I'm going to drop my wall. I'm going to take each factor out of the parentheses, set it equal to 0. When I do the math, I can kind of do this in my head right now. X equals -5 on the left. If I add 3 to both sides, x equals 3. This is my final answer. Here's how this works, and then I'll stop doing the check. The original equation is x squared plus 2x equal to 15. If I plug in that value of -5, wherever I see an x, I'm going to get -5 squared. 2 times -5. Does 25 minus 10 equal 15? And it does. That's why I know this is definitely an answer that works. Let's try this again. Let's take the second value for x, which was a 3. X squared plus 2x, is it going to equal 15? Well, let's stick in a 3. Let's stick in a 3. 3 squared is 9. 2 times 3 is 6. And definitely 9 plus 6 equals 15. So that value worked also. Okay? This one, set the equation equal to 0, which means I've got to subtract 10x from the right to the left. You get x squared minus 10x equal to 0. Well, how are you going to factor that? GCF. X comes out. X minus 10 is left over. Set it equal to 0. Drop your wall. The first equation is just going to be the GCF, or the x, equal to 0. That happens to be your first solution. The second one is x minus 10 equal to 0. Add 10 to both sides, and you get positive 10. So this should work, and this should make sense, right? Because the equation is 0 squared equals, or x squared equals 10 times x. If I plug in a 0 here and a 0 here, doesn't 0 equal 0? So this guy works. If I do it again and I say, okay, remember the original was x squared equals 10x, and now I plug in the value of 10, the other solution, I get 100 on the left, 100 on the right. So this guy also works. Okay, last one. 2x squared plus 4 equals 6x. I'm not equal to 0. I need to bring the 6x to the opposite side. And I need to realize that it has to go in the middle because I need to be in x squareds, x's, and then constants. So this would look like 2x squared minus 6x plus 4 equal to 0. Well, how are you going to factor this one? GCF is going to have to come out first. If a 2 comes out, you get x squared minus 3x plus 2 equal to 0. Well, in here, I can IM. I can't lose this 2, but when I IM, I get x minus 2, x minus 1 equals 0. And now I'm going to drop my walls. I've got 2 walls this time as opposed to 3, but understand that this 2, this GCF, is nothing to solve for because there is no variable there. In other words, if I try to set 2 equal to 0, it just doesn't make sense. So I'm really only dealing with the factors that have variables with them. So x minus 2 equal to 0, add 2 to both sides, x is 2. X minus 1 is equal to 0, add 1 to both sides, and x equals 1. So there are still 2 solutions, and the solutions happen to be positive 2, positive 1. Again, if I do some plugging in, I could take my original equation, 2x squared plus 4 equal to 6x. Well, the first value we found was 2. Exponents come first. 2 squared is 4. 4 times 2 is 8. 8 plus 4 does in fact equal 6 times 2. 12 equals 12. If I were to plug the 1 in instead, I'll put the 1 in here. If a 1 goes here and a 1 goes here, well, 1 squared is 1. 1 times 2 is 2. And 2 plus 4 is, in fact, whatever 6 times 1 is. Okay? So that's it. Make sure you set the equation equal to 0. You factor completely. You set each factor, wherever there's a variable, equal to 0, and then solve. Good luck on the homework.